All right, today let's deal with matrices. Let's do with the introduction of matrices. Okay, what is a matrix? A matrix is a set of or group of numbers arranged in square or rectangular array enclosed by two brackets. So as you can see in the example, we have three examples given. 1 and minus 1, we just put in two parentheses. The other example is 4, 2, minus 3, 0, put in the brackets. A, B, C, D, put in the brackets. So if you see this is an example of a matrix, an array of numbers arranged in rows and columns. Okay, so what are the properties of matrices? Number one, a specific number of rows and specific number of columns. So there's always a specific number of rows and columns in a given matrix. The two numbers, rows and columns, describes the dimensions or the size of the matrix. So if you see in the example, the 3 into 3 matrix refers to 3 rows and 3 columns. So if you could see in the first example, we have 3 rows and 3 columns. 2 into 4 refers to the second matrix, which shows 2 rows and 4 columns, and 1 into 2 matrix shows 1 row and 2 columns. So the dimension is being represented by the number of rows and columns. The dimension of a matrix is also called as order of a matrix. So what is the order of a matrix? The order of a matrix refers to the number of rows and columns a matrix has. So the number of rows and columns a matrix has refers to the order of a matrix. The order of the matrix is represented by the letter M and N, where M refers to the number of rows and N refers to the number of columns. So typically, a matrix is represented this way. A, capital letter A, representing the matrix, equal to, open a bracket, and then small letter A, I, J, close the bracket, M into N. So A, capital A, refers to the name of the matrix, and the small letter A represents the elements. And every element has their own specific position. So the IJ represents their position in terms of row and column. So the I represents the position in terms of row, and J represents the position of the element in terms of column. So every one of the peculiarity about matrix is, since it is based on arrangement, therefore every element has its own specific position. So as you can see in this example, every element has their own position. A11 means the element A11 is in the first row, first column. So in the given example, A23 equals to the element in the second row and the third column. So A23 has been placed in the second row and third column. So the number of element can be any number. That's why we go by the expression Mn to mean any number of row and columns. So the element Amn equals to the element in the M row and N column. So it can extend to any number of rows and columns. So it is given as Amn to mean the last position of the last element in the set. Finally, a matrix can be defined as an arrangement of elements in rows and columns where each element has their own respective position represented by I and J. And the order of the matrix is represented by M by N, where M represents the number of rows and N represents the number of columns. Thank you.